Hello everyone, in this video we will be presenting our project for the unit SIT209 Software Engineering 2 Developing IoT Applications. Our project title is Sustainable Mushroom Production. Our team name is Mushroom Minders and we collaborated as a team of 5 on this project. My name is Sohil Nagpal and other team members are Pratham Garg, Shravel Sharma, Samarth Mistry and Yuvraj Bansal. This project aims to create a sustainable and efficient system for mushroom cultivation that utilizes technology to monitor and control environmental factors such as temperature, humidity, soil moisture, and carbon dioxide levels. The project will be carried out in a controlled environment such as greenhouse or indoor farm and will be equipped with a monitoring system that collects data on these environmental factors and displays them on the web page. There are some requirements for a healthy mushroom growth. Mushroom requires a cool environment, a temperature between 12 degrees Celsius to 24 degrees Celsius with high humidity around 90% and above, and well ventilated air from 400 to 800 ppm carbon dioxide. They need a substrate with moisture content between 60 to 80%. Different types of mushrooms have different temperature requirements, so choosing the appropriate temperature range is crucial. So I would like to present you the hardware components of our mushroom growth project. Our project involves the use of an SIT30 sensor to record carbon dioxide, temperature and humidity, as well as a capacitive soil moisture sensor to measure the soil moisture content of the soil to optimize the growth of the mushrooms. Let's take a look at the individual components of our setup.
In this project, we are using the Arduino Nano 33 IoT as a microcontroller. The Arduino Nano 33 IoT is a small, low-power microcontroller board that is based on the ARM Cortex M0 processor. It has a number of digital and analog input-output pins that we can use to connect our sensors. In addition, it also has a built-in Wi-Fi and Bluetooth connectivity, which will allow us to easily connect to the internet and communicate with other devices. Firstly, we have the SCD30 sensor. This sensor is capable of measuring CO2 levels, temperature, and humidity. It has a measurement value range of 0 to 40,000 ppm for CO2, a temperature range of -40 to 70 degrees Celsius, and a humidity range of 0 to 100%. This SCD30 sensor is connected to a microcontroller through the I2C interface. In addition to SCD30 sensor, we are also using the capacitive soil moisture sensors to measure the moisture content of the soil. The soil moisture sensor is a capacitive sensor that measures the dielectric constant of the soil, which is directly related to the moisture content. The sensor is connected to the microcontroller through the multiplexer to an analog input pin.
To control the temperature in our mushroom growth environment, we have added a solid state relay module to our setup. This module allows us to switch an air conditioner on and off based on the temperature reading from the SCD30 sensor. When the temperature rises above a certain threshold, the microcontroller will activate the solid state relay module, which will turn on the air conditioner. When the temperature drops below the threshold, the microcontroller will deactivate the solid state relay, turning off the air conditioner. We have also added a button to our website that allows us to manually switch the air conditioner on and off. We have also built a website to display the data recorded by our sensor and allow us to control the air conditioner. The website is hosted on a server and uses a database to store the sensor data. We have written a script to transfer the data from our microcontroller to the database through the internet. The website displays the data in real time and allows us to monitor the conditions in our mushroom growth environment from anywhere in the world.
Lastly, to power our setup, we have built a sustainable source of power. We added a solar system to charge the battery using a smart solar charger. The solar system charges the battery during the day so that we can run our system continuously without needing to replace the battery. We also made an inverter that converts the AC power from the main supply into DC power of 1.5 to 24 volts. which is used to charge the battery simultaneously so that the battery never goes down during the night time or when it is dark, since the solar panel will stop supplying power during that phase. The solar charger then gives output from the battery to our whole system.
In summary, our hardware setup consists of an SIT30 sensor, a capacitive soil moisture sensor, a solid state relay, an Arduino Nano 33 IoT microcontroller, a custom built power system including an inverter battery and a solar system, a breadboard, and jumper wires. These components work together to record CO2 levels, temperature, humidity, and soil moisture, as well as to control the temperature in our mushroom environment using an air conditioner. We have also built a website to display the sensor in real time and to allow us to control the air conditioner remotely. With our setup, we can ensure that the conditions in our mushroom growth environment are optimized for the best growth and yield. We can also monitor the conditions remotely, which is especially useful when we are away from the location of our setup.
Hello everyone, my name is Yuvraj Bansal. For the SIT209 unit, I am a member of Mushroom Minders team. In my project, I was given the responsibility of front-end development. I therefore want to showcase my work here today. At first, this is the landing page of our project that gives an overview of mushroom farming. It includes a navbar with the links to different pages of the website, a carousel with some interesting facts about mushroom, and styling with CSS. The page has the logo of Mushroom Minders and a favicon. Here, we have to first fill our login credentials before we can access our dashboard. This is the structure of a login page. The main section of the login page contains a form for users to enter their username and password, along with the login button and a link to register for an account. Similarly, here is the register page where the new user has to register itself because before he/she can access the main dashboard. Moving on to the dashboard. In this, we are fetching the sensor data from an API endpoint and displays it as a line chart. JavaScript is used that creates a line chart using HighCharts library. The chart displays the CO2, temperature, humidity, and soil moisture levels recorded in yellow farm over the time period. The x-axis shows the hour of the day, while the y-axis shows the reading data. The HighCharts.chart function is used to create the chart object and define its properties. The chart property defines the format of the tooltip that appears when hovering over data points in the chart. Finally, the series property specifies that the data to be plotted on the chart. Data from the sensors is updated every 5 minutes using an interval. This user can select the sensor ID from a top-down menu and the chart is updated with the data from the selected sensor. Ajax is used to fetch data from an API and HighCharts to display the data in the chart. Now moving on to the Add Device page. This web page contains a form for adding a device to a monitoring system for the mushroom cultivation. The form uses jQuery to send a post request to an API endpoint with the device name input by the user. If the request is successful, the page will redirect to the charts page. In the end, we have the team page. This HTML document that displays the list of our team member on a web page. The page includes the header with the title and a navigation bar that links to different pages, including the current page. The team members are displayed in a section where their image name with their images names and roles. The page also includes a JavaScript function that toggle the navigation bar when the user clicks on the hamburger icon. So this was all from my side. Thank you.
Hello everyone, I am Shravel and I will explain you the website's communication with the server. So as you can see that we have a page of add devices. So what actually happens that when we want to add a device, we have to write in the name and the submit, and what's actually happening in the backend is we are accessing the API URL, and we are posting a new device to the API. So the API will then communicate with the MongoDB server and add a new device over there. And when we go to the dashboard, we're able to see that the data is being fetched from the MongoDB server, and it has been displayed in the form of charts. And whenever we click on any of the button, we're able to see the chart of that time duration. And what's actually happening in the backend is we are accessing the API URL to receive the data from the MongoDB server, and we are receiving the sensor data. And when we receive the sensor data, we have to plot the data on the chart. So with the help of high charts, we are able to display the data on the high charts. And we are also manually controlling the AC with the help of this button. When we press it, it goes on and off. And we are actually posting this using the MQTT server. So whenever we press on the button, we are sending an MQTT request to turn the AC on, and the microcontroller on the mushroom plants will receive the data and do selection to make the AC turn on.
Hello, my name is Samarth and I am developing the web server and maintain the security of our web pages and deploy them into the server. So this is our main page of our project, and I have developed the security for the pages. So I am going to click on the dashboard, but without login it's not possible to access the dashboard, so it will be redirect to the login page. So here we will log in. So for the security I have built this page. So I'm going to use the wrong ID and password to log in the page. So this is the wrong password and I'm logging it with. So it will be redirect to the register page, that it will show that the credentials are not true. So here is the register page, and I'm going to use the user that already exists in our database. So I am logging with the same user, and it will show that user is already exist. So it's not possible to register with the same user that already exists. So I'm going to make a new ID for the testing. So here I will name the test and test @gmail.com. This is the password of our test user. It will be registered to the login page, and I will log in it with the same username and password. So it will be redirect to our main page, and the login button will be removed from here. So when I register the same, also there is another login with Google authentication. So here I will click on the Google page. So it will be show the Google ID, and here we can log in with Google also. It will be going to access the pages, and it will show that we are already logged in with the Express session. So all the pages and API Also, all the pages and APIs are uploaded into the GitHub and that are connected with the render.com. So it will render.com and cyclic.sh web hosting. So it will be running without local host. Thank you.
So this was all about the detailed presentation of our project, including the hardware and the software part. We have the links of the GitHub and video of the hardware working attached to this description below. Thank you so much for watching the video.